3D printing is a huge hot topic right now. They're projecting that market's growing anywhere between 30 and 40% annually. So CAD is computer aided design, okay? And basically what it was created for is to recreate the hand drawing process in a computer, right? So when people were designing buildings or when they were designing manufacturing components, they used to do it by hand on a sheet of paper with a pencil and rulers and protractors. So CAD was basically recreating that whole environment in a computer environment. So it originally was created just to redraw these lines in a computer, be able to reproduce those. And then really what it's done is it's grown into a full 3D environment now. So you're using it for visualization tools. So for instance, if I'm trying to sell you a new cell phone or a new recorder, I'm going to show you what that part and piece is going to look like on a computer before it is manufactured.
Yeah.
You're also using it for simulation purposes now. So you're using, whereas before it was just recreating the drawing, now you're actually doing all of your testing and stress analysis. So I may have a helicopter engine that I'm going to run in software. I'm going to say, well, how many hours can this helicopter engine run before it's going to break down? How much stress can these bearing components take before they're going to snap? I'm doing all those calculations in CAD software now. And then I'm able to take whatever my design information is, and I'm able to translate that out to CNC machines. So for instance, machines that are actually milling or tooling components, they're taking that directly out of the CAD environment. Whereas before, you had a drawing and you would actually have to hand program each little X, Y, Z access of these machines. So it's really just streamlining the whole workflow of getting from basic conceptual design all the way to the manufacturing process. And then you use things like the scanners for inspection purposes on the back end. So a couple main uses in 3D printing. Number one is prototyping. That's still probably the number one use for it out there, especially in the manufacturing world, is prototyping. So if I'm using CAD, if I'm using SolidWorks, for instance, to design some sort of component, I actually want to have a prototype or a part or piece of what that's going to look like before it ever goes to a manufacturing environment. Well, before I might have to send that off to some steel fab shop and spend $5,000 to $10,000 or more for them to actually build me this part. And that might take 2 or 3 weeks, and I may want to tweak a design and then re-prototype it again. And so all of a sudden you start stretching your design and R&D process out tremendously. Well, now 3D printing, you take your part or piece in SolidWorks, for instance, you hit print, you come back the next morning and you have an actual 3D to scale model of what your part or piece is going to look like. And so now you can manipulate and say, hey, how's this going to hold? Is it going to fit into whatever I'm going to use it for? So prototyping is a huge piece in the R&D world. The other piece, we use some of the color printing technology for early conceptual design. So we're talking about, if I'm conceptualizing a pair of sunglasses, I'm going to 3D print maybe a couple, maybe 3 or 4 different designs, different colors, different thicknesses. That way our CEO or market study teams can take a look and say, hey, I like this one, I don't like this one, I don't like this one. So it's bringing that a lot quicker into the design process. And then really right now, 3D printing is taking off in a production environment. So for instance, in a Formula One race car, they make design modifications, these things every single day. There are some air ducting manifolds that are so complex to manufacture. You can't mill it, it's very tough to cast. So really complex parts and pieces, you're actually 3D printing and you're putting that part or piece into for the final use. So a lot of the Formula One race cars, a lot of their air ducting is actually 3D printed. Prosthetics, for instance, you lose a leg, or they can go through and they'll scan your leg, and then they'll basically 3D print you a prosthetic leg. It'll fit exactly onto your leg because it's been scanned, and then you can 3D print it to any shape that you want to. So one-off, or maybe if you're doing 5, 10, or 100 parts and pieces, it's way too expensive to set up a whole manufacturing environment, so you're going to use production print to do that. And then we also have printers now that'll print steel alloys, stainless steel, aluminum, nickel, titanium. So custom metal parts that, hey, somebody needs 4 fan blades. They're extremely complex. It's going to cost me $100,000 to send it to some major manufacturer for them to set that process up. I'm just going to print my 4 parts in nickel, for instance. And so scanning it can fit in 3D printing in a couple different ways. So one is if you just want to recreate an existing part for prototyping purposes, or even you want to print, let's say I have a metal pump housing. I'm going to scan that image. I'm going to be able to take that scan into a 3D print environment, 3D print it, and basically reproduce my part or piece. So you're integrating it there. They're also using 3D scanning to actually scan 3D prototypes, for instance. They're doing custom castings. So if, in a manufacturing world, there's a lot of castings used. They may be able to scan an existing piece, and then you're going to 3D print the casting that you're going to use to remanufacture that part or piece.
Okay.